In this video, we're simplifying expressions that have rational exponents. Looking at example A here, we can see that they want us to raise this term to the power 4/3. Remember what we do with that situation, we actually distribute in this exponent, correct? And what's nice about this is that when you have x to the third, that's like 3 over 1, right? And it'll be times 4 over 3. And then it'll be y to the 12 over 1 power times 4 over 3. Well, what's good here is that 3 will cancel with the 3 here to give you just x to the 4 over 1 power, or x to the 4th. And then for y, the 3 will go into the 12 4 times, giving you 4 times 4, or in other words, y to the 16th power. And so you end up just having x to the 4th, y to the 16th power as your answer. Okay, so for example B, we're going to be distributing in the 1/6 power here for this term. So it'll end up becoming x to the 1/6 power, y to the 1/6 power. Then here we're going to distribute in a half. So what is half of 2? Half of 2 is just 1, so it'll be x to the 1 power, and then we'll bring in the half to the y to the second power. It'll become y to the first, right? Because again, half of 2 is 1. All right, and then we'll divide by, bringing in 2/3 here to the denominator term, we'll have x to the 2 times 2/3. So remember, that's going to be 2 over 1 times 2 over 3. That'll end up giving us 4/3. Then it'll be y to the 2/3 power. Okay, so rewriting this a little bit. In the numerator, we have like terms, so we're just going to rewrite them so they're next to one another. So x over 1, or x to the 1/6 power times x to the 1 power. Then we'll have times y to the 1/6 power times y to the 1 power, all divided by, that'll become, on the denominator there, x to the 4/3 power, right? Because these fractions multiplied end up giving you 4 over 3, and then y to the 2/3 power. Okay, very good. Continuing with that, we're going to have x to the 1 plus 1/6 power, right? So we're going to add 1 and 1/6. We can write a fancy form of 1 over here. We can rewrite that as just what? 6 over 6, right? It's a fancy way to write the number 1 because 6 over 6 is 1. And then if you have a common denominator, when you add these two fractions, you're going to end up getting what? 1 plus 6 is 7, so it'll become 7/6. All right, good. And then from there, you've combined the x's. We'll do the same with the y's. When multiplying common bases, you keep the base and you add the exponents. And once again, 1/6 plus 1 is going to give you 7/6. And then in the denominator, we will have just x to the 4/3, y to the 2/3. If you're dividing two things with a common base, keep the base and subtract the exponents. We'll end up having 7 over 6 minus 4 over 3. And then for the y, we're going to have 7 over 6 minus 2 over 3. So again, we kept the common base here of y, and we subtracted their exponents. We kept the common base of x, subtracted the exponents. All right, so our final step of this process then is to simply simplify those fractions in the exponents. So it'll be x to the 7 over 6 power. To rewrite 4/3 with something with a denominator of 6, we're going to multiply top and bottom by 2, giving you 8/6. And then for the y, it's going to be the same. We're going to have 7/6 minus top and bottom will multiply by 2. We'll get 4/6. Okay, so once you have that done, we need to do one last final thing, which is to say, let's subtract those exponents. So it'll become x to the 7/6 minus 8/6 is going to end up giving you negative 1/6. And then y to the 7/6 minus 4/6, which is going to end up giving you 3/6. Okay, so to finish this problem, lastly, it's kind of a long one, we're going to end up saying that y will stay above. 3/6 can be reduced as 1/2, so we might as well write that as 1/2. And the x to the 1/6, we're going to bring that down below the fraction bar because we want to make the exponent positive. So remember, in order to make an exponent change its sign, you have to move the term across the fraction bar. So we bring that down so it becomes positive 1/6. I reduced the exponent for y to 1/2 because 3 over 6 is 1/2. And that's it. That's our final answer. Took a while, but that's the solution. All right, and then we're going to do example C finally. For example C, we need to start out by distributing in that 3/2 exponent. So we're going to say it'll be 16 to the 3/2 power, right? Because the 3/2 needs to distribute to every term, even the numbers. Then we're going to have 3/2 times -1 to give you -3/2 on x. Then the y will end up being 1/3 times 3/2. And then we can simplify that in just a moment. All right, in the denominator, we'll bring in the 3/2 times the exponent on x. So it'll be x to the second times 3/2. And we can write x to the second as 2/1. And then we'll have the same thing for the y. We'll bring in the 3/2 on the y. We'll get y to the 3/2 power. All right, very good. Let's continue a little bit here. We can clean up the exponent on the y there in the numerator. So it'll be 16 to the 3/2 power, x to the -3/2 power, and y to the, notice the 3's will cancel when you're simplifying the exponent, so you'll just get y to the 1/2 power. In the denominator, you're going to have x to the 2's will cancel there, so you just have x to the 3rd, and then you'll have y to the 3/2 power. All right, so remember, we want to make sure that your exponents end up being positive. We don't want to have negative exponents, and we want to combine any like terms that we find in the problem. So it looks like I can, just leave the 16 to the 3/2 alone for just a moment. We'll get back to that. Let's tackle the x's. The x to the -3/2 really should be taken to the bottom of the fraction, so that it ends up becoming, in the bottom of the fraction, x to the 3rd times x to the 3/2 with a positive exponent. Remember, when you cross that fraction bar, you change the sign of the exponent. Now for the y that was up there was y to the 1/2. The other y at the bottom had a positive exponent of 3/2. So here you just need to move the smaller one to meet the larger one. So what I'm going to do is I'm going to bring that y to the 1/2 down below as well, so that it ends up becoming negative. And normally we don't want to make exponents negative, but we're going to combine the like terms here. So what I'm going to do is bring the smaller one to the larger one, so that in the end, we end up having 3/2 times y to the -1/2. And you'll see that in the bottom now, because I brought the smaller one to the larger one, we will end up with a positive exponent. You didn't have to do it that way, but that way will certainly work. So I just wanted to demonstrate how that's done. All right, very good. So let's do a little cleanup here. 16 to the 3/2 power is really the same as the square root of 16 to the 3rd power, because remember, this 2 can swing around and become the index of the radical. Let's first deal with the x's at the bottom. So we'll keep the common base here for these x's, and we'll add the exponents. So we need to add 3 and 3/2 together. And then we'll do the same for the y. It'll be y, keep the common base, and add the exponents. In this case, the exponents are basically positive and negative, so we're going to subtract the exponents. Okay, continuing on the next line. The square root of 16 is 4. We'll raise 4 to the 3rd power. We'll do that in a minute. Then we have to add the fractions here for the x. So 3/1 and 3/2. Well, if I want to write 3/1 as a fraction with a denominator of 2, I'll multiply top and bottom by 2. That'll end up changing this 3/2 to basically 6/2. And then 3/2 and 6/2 make 9/2. So we're going to end up having 9x to the 9/2 power. And then for y, we do the similar kind of thing. We'll keep the base. Go ahead and subtract those exponents. They have a common denominator, so it's just going to be 1 left over. Will be what we get, because 3 minus 1 is 2 divided by 2. So we'll end up having 2/2, or 1, as the exponent for y. All right, the final thing then, of course, is 4 to the 3rd, which ends up giving you 64. And then finally, x to the 9/2, that can be left just as it is. And then finally, y to the 1 power, or just y. So a very long problem, but that is how it's done. And we're finally finished.